Sorry. So, Christian, take it away.
Yes. Mic okay, so? Okay. So, hello everybody. I'm Christian Cherek from RWTH Aachen University, and I'm going to give this on behalf of my colleague Moritz Wittenhagen, who cannot be here today. So, it's about source code history interaction. So, why should we do that? I mean, Trudy just gave a good example why you might want to do that. Basically, sometimes you want something to go back where it was before, and to find a version that you have to find is sometimes really difficult. And back in 2010, Latosa and colleagues actually collected a set of hard-to-answer questions about source code. And many of these questions regard the history as well. And some of them can be easily answered with version control systems, like who did this change or what was changed recently. But some are really hard to answer when you only have access to single files. So has something always been this way, for example, is really hard to answer there. And that's something that we wanted to make better. And what we did is we made use of the structure of source code, basically. So as we have a file that evolves over time, oftentimes we add certain objects or we change the structure of the file. So it's basically in between you save a version every time and you have small changes that then at the end create your whole project. But what all these have is basically that objects that are there keep in the same place. The structure might change, but like for example the blue if block will do the same thing probably and only change in steps. So what we did is we created a structure that makes use of a simplified version of the syntax tree of source code. Basically, objects that are within another object are child nodes from that. And when we do that for all file versions that we have, what we then can do is we can try to match nodes with each other. So now we know each node's predecessor and successor in time. And when we do that for all nodes that we have a structure that we call the history graph. And on this history graph, you can do interesting things when you want to navigate between the different versions of a file. So, for example, imagine when you have your viewport. So basically, what you're looking at in code right now at a certain position, as we now know where in the history graph we are, we basically can move this viewport as we navigate through history up and down to always be on the same block that it was before, and thereby make it a lot easier to look at this certain object in code. Or when you imagine that somebody selects an area, for example, the green one, and highlights it, what we now can do, as we know which objects are connected to this, we can propagate this feature of being highlighted through all versions of the file, so make it easier for users there. And note, it's not only useful to propagate, for example, highlighting, but you also could propagate other features, like an interesting comment that was introduced at some point. You can propagate this through the whole history. But you can also do interesting things with the history graph itself. So imagine, for example, if you want to take a closer look at a certain area of the graph, let's say, again, the green one, what you can do is you can filter out the rest of the code and the graph to only look at this specific subgraph of the history graph and thereby get a better overview. Or the other way around, if you say, I want to see the whole code, but I don't want to go too deep into detail, you can abstract this and basically decide to only show the graph up to a certain depth of the history trees. And all these features are really interesting when you want to navigate on files. But still, these trees are kind of difficult because they do not really relate to source code. So what we did is something that is actually really close to Code Flows by Telea and Auber from 2008. So what we create is we create for each of these trees, we create a one-dimensional representation. And as we have the connection, because we matched the nodes, what we now do is we create cubic Bezier curves between these one-dimensional representations. So now we get a nice flow visualization, how the code actually evolved over time. And this is what it looks like in our tool. So just to give you a short introduction, things that you can see here directly are, for example, someone added something to the code, and that's a pretty big block, and it appeared just in this version. Or at this position, something was removed from the file. Or another really interesting thing is the copy and paste event that happens a lot as well. So in this area, the small green one was actually copied and pasted out of the yellow one that existed before, and was evolved afterwards separately. Or a little bit later, the same block was just moved within the file. So it probably changed as well, but it was moved down as well. So if you don't have this visualization, you might easily get lost because it's not at the same position in the file anymore, but with this it's really easy to see. So this is what our complete prototypes look like. Basically, the top is a code view with highlighting that matches the tree flow visualization at the bottom, and you get a small slider that you can move around and thereby select which version you're looking at in the code flow, basically. So just to give you a quick view how this looks like for a really big file, this is taken from a framework that is publicly available online. The file has about 100 versions and is pretty long. And as you see, when the user navigates through the file, the tree flow at the bottom, when something is highlighted, it will be in the flow in the code view on top as well. And as he navigates through history, the viewport stabilization feature keeps this part always in the viewport, so you don't have to scroll up and down to find it again if it moves within the file. For the other parts, for example, abstraction, when you look at this example, you might want to say, okay, I'm not really interested what is happening in the red area, so we added a feature that you just decide to, I want to look only at the very top level, so now you can get a better overview what is happening in the file. Or if you say, I'm only interested in the red area, you can also double-click this and then get an overview just for the red area. And that's basically the very, very small interaction with our prototype. So to evaluate that, we basically were really interested in how do users approach navigation when they have this tool around. Because, yeah, what do they learn about code that they did not learn before? And for that, we conducted a user study with 21 developers from a local mailing list, some university students, some professionals. And we gave them 3 different tools. The first one is Chronicler, as I just described it. The second one was a timeline slider that had the viewport stabilization feature. So as you move it, something that is highlighted will be in your viewport. And the third one is a timeline slider that did not have the viewport stability feature as well. So when you move the slider to select a different version, code might jump around because it just moved within the file. Our study consisted of 3 different parts. The first one, we gave them navigation strategies, tasks basically, and wanted to see how they think when they have these tools. The second one was smaller local undo tasks, so we asked them to find a specific version again. And the third one, we invited them to bring their own repository and take a look at code that they already know, if they probably learned something about code that they're really familiar with. So for the results, as I said, in the first part, we created a set of source code understanding tasks that were loosely based on Latosa's questions. So we had something like, where does this method come from, for example? And I just want to highlight some interesting results that we had. The first thing that was really interesting to see is that all developers were really eager to tinker around. So regardless of which tool they had, they could use all 3 in this part. They directly started tinkering around, making assumptions about the code, trying to find something again, and making assumption on what the visualization might mean. So that was really interesting to see. Secondly, when developers had the visualization, they were a lot more interested in looking around. So even if we had a task like, look at this specific method, they started to looking around and explore the code lateral top and bottom of this method as well. And thirdly, when developers had this easy view on structural changes, as the tree flow visualization gave them, they started looking at these specific events a lot more. So if something stayed similar over time, even though there might happen a lot in between, just no structural changes, they focused a lot more on these structural events, like something was added or copied. Yeah. For the second part, we wanted to find out if a task like, I remember something was some versions ago and I want to get this back quickly, if a task like this could be easier with these properties as well. So we created a set of 8 navigation tasks, and since users did not know this code, we gave them small cheat sheets where they could see the current version that they were looking at, and they got the other version as well that they should find, so they could make them familiar with what they have to find in the code beforehand. And then for this part, we made an in-between group study, so every developer had only one tool available. We had 3 hypotheses for that. First one, viewport stability. If you have the tool that keeps in focus what you're looking at, you will be faster to find it. Okay. But secondly, what we thought is if you have a structural change, like in this example, the addition of the else, you might find that more quickly when you have the whole tree flow visualization from Chronicler available. And thirdly, if you have a change that is not represented as a structural change, like a renaming, for example, then this will be probably harder to find when you have the Chronicler visualization, because you basically are focused away from events like this. So for results on this, yeah, as you see, it's actually significantly faster if you have viewport stability around. So the yellow bars are for the simplest version here. Especially for big files like task 3 and task 6, users got easily lost when searching for a specific thing, and therefore took a lot of time when they did not have viewport stability. So hypothesis 1, we can accept that. However, the structural changes or not structural changes did not affect their performance here. So timing-wise, they were not quicker or slower when they had the other tools around. Perhaps something that developers could learn if they had the chance to work more with the visualization. But yeah, that's something that we could not see in our study. So for the third part, as I said, we invited our developers to bring their own repositories, because we wanted to know what knowledge do they gain about their own code when they look at these visualization tools. So again, in this tool, in this part, they were allowed to use all 3 tools, but basically all developers decided to only work with Chronicler, as this was the most interesting for them. And I want to highlight just some things that they quoted basically when they worked with that. So many of them actually started verifying their structural soundness of their own code. So we had a comment that said, with this tool, I can see that my code structure is totally messed up. I should fix that for my next version, because basically he had a plan how the structure of the code should look like, and he stepped away from this plan after a while, and that was easily visible with the visualization. We also had developers commenting on collaboration. So one developer said, last week I had the problem that my colleague added something to the file, and I saw that in the commit message, but I had really difficulties to find this. So with this tool, I could easily see where something was added and directly look at that, and not have the problem to look around in a big project where this happened. And thirdly, we had a professional developer from a company that was really into communication with its customers, and he said, this tool would help me a lot to identify the age of a bug. So there's basically a block of code that is flawed, and as he now can easily see where this comes from and how old this is, he can find out which branches of his project are actually affected by this bug, and thereby inform his customers to say, you need to update your file because we have a bug in your version of our project. So yeah, these really interesting results that we have there, and we have a lot more in our paper as well. So if you want to take a look there, that's really interesting. With this, I'm already done. So I'm happy to answer your questions if you have any.
Yan Chen from University of Michigan.
Mm-hmm.
So very interesting talk, and I was wondering, when you decide two pieces of code, they are mapping together, like using the same color, what's the granularity over there? Like how, if I say I have an if-else statement, but I keep that, totally change the content or the functionality.
So how we do match the nodes in between.
Yeah.
For this tool, we basically used a bag of words approach there. So we basically looked at each block individually and looked what is in there in words, and then tried to match them. And if they have a higher score, then we matched these. The current version, sometimes if you have really small blocks of code, so just if one statement and then it's already gone, sometimes you have mismatches as well. But as soon as you have a block that is 10, 20 words long, the matching was really, really good. So, okay. But that's something that we had to tinker around with as well, yes.
Okay, thank you.
Hi, Yang Seok-yoon from Google. So I really like this work. One thing I wasn't really clear from the presentation was that, so you talked about this, local undo task you gave to the participants. So when the user finds the desired version by navigating through the your tool, and you find the version, then what happens next? So what does the user have to do to actually return the code to the desired state?
Okay, so for our study, we basically stopped at the point where they said, okay, I found the version, now I want to do the next task. So just for the study, that was a pure timing measurement. But our prototype basically supports highlighting and copy and pasting. So what you could do, and that is what we would imagine this tool to be implemented in as well, is that you navigate through to the version that you want to look at. You basically select the part that you want, you copy it, you navigate back to your actual version that you're working on, and you just paste it again. So
just to be clear, so the previous versions are just view only, and you can only edit the most recent version?
You cannot edit them, but you can select them and copy them, yes.
Okay. Thank you.
Mm-hmm.
It's quick. Brian Bailey, University of Illinois.
Mm-hmm.
So repositories are often littered with what I would call thinking check-ins. So they're less intentional. It's just, I want to capture this moment because I think this code is sort of correct.
Mm-hmm.
How susceptible is your visualization to lots and lots and lots of check-ins where people are just sort of in thought, in progress of thinking about the code and its evolution towards stability?
Yeah. So in general, the visualization does not need the code to be running or compilable, of course. But as you saw in the example with many, many versions, it gets more difficult to look at the file if it gets bigger and the versions get bigger. That's true. But that's especially why we have tools like the abstraction and the filtering tool. So if you have a really big file and you typically do not want to look at all of it at the same point. So you just basically select the block that you're interested in, the method or the class, double-click it, and then you get the whole representation filtered down to only the part that you're looking at. And that makes it a lot easier to look at these as well.